Hello, everyone. My name is Mark Duffett, and this is Capstone Group 13 from ECE, and our project is for the Subsea Resident AUV. So our team's comprised of Mark Belbin, Mitchell Stride, Andrew Nash, and myself. And we also have two team members who are not in Professionalism 2, Francis Walsh and Mohammed Barama. So our primary use case has been subsea oil and gas inspections. And what we've been specifically looking at is a way to use autonomy to improve how things are done. For instance, there are subsea assets and infrastructures that need to be inspected annually or on an ongoing basis, and that's currently done through a set of existing systems that have high overhead. So if we can use autonomy to do this, we could say inspect the structure of Hibernia or Hebron, which is a fixed concrete structure, or we could inspect pipelines or go and inspect trees or any other subsea asset routinely. Typically, subsea inspections are done by divers, ROVs, or AUVs. Divers giving us the most dexterity and human control and are capable of light intervention, but have extra personnel risk, obviously because we are sending people underwater for extended durations under high pressures. ROVs are another existing tool that are used, but they often require an additional supply vessel, constant crew and maintenance overhead, and then AUVs are the third existing method. They are typically not used around subsea assets, but can cover a large area doing scans, but typically do not have much of a payload system. The key thing to note is that all three of these current inspection systems are launch and recovery restricted in many ways, whereas launching and recovering from a vessel during tough seas is the most risky procedure or very risky procedure involved with each of them. And if the seas are really high and you would like to do an inspection, well, it might not be safe to do so. So that's where our solution comes in. Our solution is using a subsea resident AUV. So an AUV, an autonomous underwater vehicle that can live in a garage or a dock, which is connected to internet and to like wireless power transfer systems. So it can charge in the dock, get mission data, and then go out and fly a pre-prescribed mission on demand or routinely over time. And this way, it can go inspect things when it might not be safe on the surface to normally do so, or it can do routine scans of, like, say, pipelines or chains and look for any degradation or leaks or any other hazard and report back on a routine basis that may actually catch bad issues before they happen.
The environmental impact. While the SRAUV primary design goal initially was not how can we save the environment, we analyzed what impact the project had through its carbon footprint for itself and its applications. On the surface level, the SRAUV is a robot or vehicle that took resources to produce. Looking at its entire life cycle, similar to a car, you have to consider the mining of materials, manufacturing, usage, and end of life. But what impact will the project have to offset this? As long as the oil industry is active, that means potential oil spills. So what can our project do to help? One example is the recent Husky Sea Row spill in 2018, which is currently the largest spill ever recorded in Newfoundland's offshore. The cause of the spill was a failure of a critical connector. This kind of fault could have been detected by more frequent inspections. Continual inspection instead of periodic inspections for underwater assets and pipelines provide many benefits. By constantly monitoring underwater pipelines and drilling sites, we can identify potential issues and prevent spills before they even happen. If the product caught one major spill beforehand, that will cover all the SRAUV detriments to the environment, like carbon emissions, energy, and construction of the bot and installation. So the project can create a net benefit for the environment through the application and usage of the product. During the 2018 Husky spill, the adverse weather conditions delayed the investigation of the spill, which allowed the spill to disperse and became impossible to clean up. The SRAUV would eliminate the traditional inspection time for boats, divers, and ROVs. A side benefit is this also reduces the large CO2 emissions of surface vessels. The main benefit here being minimizing the time that oil is poured into the ocean. So what about green or renewable energy? Another application is offshore wind turbine inspection. In an array of turbines, one SRAUV could be installed and responsible to inspect 25 turbines and do 1 or 2 a day. Continual monitoring of the anchoring, cables, poles, and mooring has potential to improve maintenance, reliability, and even operational uptime. Anything to improve the effectiveness of wind turbines is a great step for the renewable energy industry. Similarly, this could be even used in a hydroelectric power generation or a dam. So to conclude, while the technology overall isn't something obvious like tree planting or recycling, the applications and use case of the SRAUV has great potential to protect our oceans and be a great example of a green product through its impacts.
Hello everybody, I'll be talking about some of the societal impacts of our proposed solution. Now, while our autonomous project could be a great boon for offshore companies and also has the potential to reduce severe industry environmental impact, it's important to consider its impacts on what current solution it replaces, namely the crewed offshore vessels with workers and operators that inspect these subsea assets manually. Of course, by eliminating the potential need for a fully crewed vessel, there will be less demand for crew to operate these vessels. This means less jobs. However, it's possible that even though the number of workers required may be reduced, those who are still a necessity could have increased pay and benefits due to operation efficiency. As well, companies may use extra capital saved in order to invest in adjacent projects, which could increase the demand for offshore workers in adjacent fields. However, if companies don't reinvest, there may be motivation to increase offshore royalties or taxes, such that autonomous technology truly is a benefit to all and those it replaces. Another important potential benefit from implementing our autonomous technology could be to make the offshore safer for all workers. Offshore oil and gas is one of the most dangerous industries in the world and has been known for its disasters. Having an autonomous inspection vehicle could eliminate the need for some crew to spend so much time offshore and allows for the continual inspection of fixed assets. This means that fixed assets like large oil rigs could be inspected continually, which would increase their safety and be a benefit for all workers. Increase the safety of offshore workers would be a major benefit to society at large.
So it's really important for us to understand the ethical and societal impacts of our project. At first glance, it really doesn't seem like there's any huge impact. Perhaps we build the best system ever at detecting subsea assets and helping prevent environmental problems before they happen. Well, that's great because our clients, their costs are lowered and we make this fantastic environmental impact, but we don't really have a big impact on society and there's no huge ethical dilemma. But it would be negligent for us to not take a further step back and look at this bigger industrial revolution that we seem to be a part of. A lot of people are calling this the fourth industrial revolution, where essentially robots are replacing a lot of human jobs. And companies are incentivized to do this because robots are cheaper and are better at the jobs. You think about call centers, soon enough, AI will replace every single call center worker and be better at doing their job for free. You think about autonomous cars. Well, soon enough, cars are going to be driven by an AI by itself. And guess what? That's a lot cheaper than paying a taxi cab driver. And you think about people who work in manufacturing. On these manufacturing lines, you have these big armed robots that are more precise and quicker than humans at assembling things and doing these onerous labor. So thanks to Stats Canada, we can actually kind of break this down a little bit and see what jobs are at highest risk. You see, manufacturing is the biggest one, accommodation and food services being another, transportation is sort of where the autonomous vehicle is where kind of we fit, or down here in sort of the scientific and technical services. But you see, in all these jobs, we can find ways for robots to do human jobs better than them. And we can see that a lot of the jobs that they're replacing are sort of on the lowest end of the education spectrum, meaning a lot of people whose jobs are being replaced don't have high school diplomas or didn't complete high school. But you can see that everyone in every sort of area of the spectrum of education is at risk of some form of automation. And these are not substantial job losses. We look at just the autonomous vehicle space, and it's 1.1 million Canadian jobs. That's not a small number. And we look at the grand scheme of things of all of automation, and we're looking at 10% of jobs at high risk, and then 40% of jobs total at an overall 50% higher risk, classified by Stats Canada at being replaced. That's a lot of jobs. What happens when companies decide to automate away 50% of Canadian jobs? That's a bit of an ethical dilemma. How do we solve that? What do we do? Is it okay for that many people to lose their jobs? Can we move these people to more productive jobs, or will they forever be stuck and not have a job? Well, there's a lot of solutions to sort of this problem, like, well, what do we do? Some people think that universal basic income is the answer. So giving people X amount of dollars every month. This could be positioned in a way where it's enough to pay for all of your living expenses or only some. Some people think that we should retrain workers, though if you look at the statistics, this has an incredibly low chance of actually putting someone back into the workforce. Some people just think we should lower the barriers to higher education, meaning you saw a lot of the jobs that are being replaced are sort of on the lowest end of the education spectrum. So maybe we can just educate everyone more, and then everyone can still create new jobs and contribute sort of at a higher level. But I can't tell you what the right answer is, and I don't know if anyone can tell you what the right answer is. But it's important that we're aware of these problems that sort of we're participating in and contributing in, and do our best to understand and do what we can to help.
As a summary, we have explored the example use case of an oil and gas inspection vehicle and designed a prototype SRAV that we've been testing in the deep tank at Memorial University to hopefully better understand the problem and our potential solution. We have explored the technical and environmental benefits of using an SRAV in this application, as well as societal and ethical impacts of autonomy itself.
Thanks for watching our presentation, guys. Let us know if you have any questions in the discussion thread. Thank you.